Welcome to qnawire.
Problem 746, a 2.8 kilogram block slides over a smooth, icy hill shown in figure 746. The top of the hill is horizontal and is 70 meters higher than its base. What minimum speed must the block have at the base of this hill to pass over the pit? So the pit is right here, so we're assuming that it's going to be taking a little parabolic arc as it goes down to this point here. Okay, so to start off, this needs to be set up as a kinematic problem. Then we'll get into conservation of energy later. So we need to first find, I'm going to first find what the velocity is here at this point. In order to do that, I need to find what the two pieces are. There's v of x and there's v of y. So in order to use both, I need to find how much time it takes to travel. Okay, so in order to go down from an elevation of A to B, that's going to be, there's only going to be gravity acting in that dimension. So I need to set up the distance is equal to 1/2 AT squared. So that's going to be 20 meters. The difference between those two, 70 meters minus 50 meters, is equal to 1/2 G T squared. This is from the basic kinematic problem, kinematic equation, where you would have the initial velocity plus the initial distance plus the initial distance times time, velocity times time, plus the acceleration portion. Okay, so then this gets us t is equal to the square root of 40 over g. So that's going to be 40 meters divided by meters per second. Okay, so then what we do now is we write Vy is equal to gt, because that is starting from 0. It goes down for a certain amount of time at acceleration. So then that's going to be the velocity in the y direction at that point. So then that's going to be square root of 40g. Okay, then Vx can be found by simply doing distance divided by time. So here it needs to cross 40 meters in that amount of time. So then what we're going to get is we're going to get 40 meters divided by square root of 40 meters over g. It's in meters per second squared, meters per second squared, and that's going to be equal to square root of 40g as well. Okay, so then our final velocity we can find by writing the sum of the square root of the squares. So then we can write v is equal to square root of vx squared plus vy squared. So the square root of the sum of the squares is going to be equal to the square root of 80g for velocity. Okay, so that means that this is going to be the velocity here at this point. It's going to be that direction, but it doesn't matter for our conservation of energy considerations. So here we're going to set up our conservation of energy. We have initially only kinetic energy. That's going to be 1/2 mv1 squared. It's going to be at the first point is equal to the height at this point, the potential energy at this point due to this height. So we have mg times 50 meters, and then plus our kinetic energy at that point. So we're going to have 1/2 m, and then here we have, I'm going to write vb there. We have vb squared. Okay, so we have masses that can cancel out. We have 1/2 v1 squared equal to 50g plus 1/2 times 80g. Okay, so then we get v1 squared is equal to 50 plus 50 plus 40 is 90, so times 2 is 180 G. So then we get V1 is equal to the square root of 180 G. Okay, and then that should get you a number, and it's going to be meters per second.